So, John and Miguel, welcome. We are all yours.
Thank you very much. All right, let's get going then. So welcome everyone from the Cisco customer experience team. Today we're talking about the title of today's session is Let Cisco Catalyst Center be your guide to a zero trust workplace. And as Alex just said, it's part of the Catalyst Center Expert Insights. And Miguel and I are your hosts today. And for the purposes of just reading all the text on the slide, today is the 21st of May. Okay. Not going to make a habit of reading all the text on the slide. Let's just do some introductions then. Firstly, I'm joined here with Miguel. Miguel, if you want to give yourself a quick introduction.
Yeah, absolutely. Thank you, John. Yeah, my name is Miguel. I am a customer success specialist, focused on Catalyst Center, just like John. And yeah, I've been here in the UK for around 6 years, and happy to be here.
Nice. Have you got a good little fact, outside of work fact for everyone? I'll put you on the spot now because I didn't say I was going to ask you.
Yeah, facts about me.
Yeah.
Oh, yeah. Let's say I come from the Dominican Republic. That's something that everyone in the UK, when I tell them that, just tell me, like, what are you doing here?
Nice,
Because
nice.
of the weather, and yeah, I think.
Awesome stuff. And that's why I popped your Dom Rep flag down there as well, which is pretty cool.
Yeah.
And so my name's John. I've been at Cisco now for about 11, 12 years. And you used to be an SC and moved over to be a CSS, and Miguel and I do the same thing. A little fact about me: I'm a WBQA judge, which is the World Barbecue Championship judge. So I've flown around and been a judge at international food competitions and stuff like that, just in my spare time. Nothing to do with work, but just a bit of fun. Miguel and I, we actually live about 5 miles apart from each other, which is quite nice. And so occasionally we'll make a trip down to see each other. And he keeps inviting me over for dinner so I can try some amazing Dom Rep food. And I haven't been over yet, but that sounds amazing. And so, but it's similar to today's theme of technologies of working together. Miguel and I spend a lot of time together, but also the technologies we're going to talk about today, working together to create a zero trust workplace. So today, Miguel and I are going to be your guides on your journey to a zero trust workplace and show you our recommended path. Okay, so I want to start by telling you a story of a fish tank. So this fish tank in particular is in one of the Las Vegas hotels, in one of the casino hotels. And the fish tank in particular is in the lobby. And I want to talk about the thermostat, which is in the fish tank. This is a smart device. And so so the smart device, this thermostat, regulates temperature without any human interaction, which is great for the fish because they get the temperature that they need. Great for humans because we don't have to waste our time monitoring and managing the thermostat and the water and all that sort of stuff. The smart device does it all. But there is one particular person that has a specific interest in this device, a hacker. So this hacker knew how to exploit the security vulnerabilities of this device. He was able to infiltrate the network just because of the thermostat. He was able to move laterally through the network, which means critical resources were not isolated from the thermostat. And this means he was able to exfiltrate all the customer data from the hotel to a remote server back over here in Europe. And in total, that was in excess of 10 gig of data taken from this hotel. It's just a small, tiny, irrelevant device, but this was the back door to the whole network. And this isn't just a fictional story. This isn't just something we've made up. This actually is a real event that happened back before the whole COVID pandemic in July 2017. Now, what actually happened? All systems went down, check-in desks stopped checking people in, lifts stopped working, casino floors stopped, bars stopped serving drinks. It was a huge disruption for the business and its customers. So I'm talking about this example today to ask one question where we can give you the answers from a Catalyst Center perspective, plus some friends, obviously. The question is, could it have been avoided? What do you need to do to not be the next fish tank story in the news? Any device can be a backdoor for a hacker. Miguel and I work in the Catalyst team, And all too often we witness businesses thinking about security as something that you put on top of the network, like a security appliance. And well, that's great. I mean, everyone does need security appliances. I'm not saying don't buy a security appliance. You can't leave the top of your network open. But it's a bit like when you secure your home and you put an awesome secure door on the front with amazing locks, and no one at all is getting through that front door. But you leave all your windows open, so anyone can walk past that awesomely secured front door and just climb in through the window. So that's kind of how we're looking at this. And then in order to close the windows, we need a paradigm shift. So we don't just bolt security on top of the network like a separate facet, but you need to think about integrating the security within the network. So integrating Catalyst Center in the plan, as this has a visibility of all the devices, all the clients, all the traffic, and so is best place for ensuring your security within, not just halting threats through the normal top-down data flow. So with security in network, you gain more benefits, more use cases. For example, you can enable the zero trust framework to secure the workplace and clients. And everyone has a different definition of zero trust, but regardless, a zero trust network always has the same principles at its core. Never trust any devices or people, even if they're authenticated and originally authorized. And this was the first mistake of the hotel in Vegas. So they bought the smart thermostat, installed it in the tank, and trusted it. It's only measuring the temperature of water. What could possibly be a danger about that? What they should have thought was, let's give it the least access and least permissions possible for it to do its job. So one part of the Zero Trust framework is visibility. We're going to be talking today about endpoint visibility in this session. So what is connected to our infrastructure? Who is the manufacturer of the devices? What is the operating system on the devices? If there is any unknown endpoints, and how do we identify them, and how to reduce those unknown endpoints? When you understand your endpoints that are using your infrastructure, you know what traffic to filter, what access control you need, and all that sort of stuff. If you want constant protection, you need to constantly monitor. And this was also the mistake of the hotel. They assumed the trust automatically and then never monitor the device in the fish tank. If they had continuously monitored the devices, they would have noticed that the traffic from the thermostat is not normal, not typical. Ports and protocols being used that are unusual for the device type. The fact that 10 gig of data was exfiltrated, again, not normal for a smart thermostat. Should a thermostat be reaching out to the customer database server, for example? We want to monitor your devices, to monitor your endpoints, give you the ability with Catalyst Center to detect anomalies. And when an anomaly is detected, not an anemone, because that might normally be in a fish tank. When an anomaly is detected, we want you to have the visibility of the issue and the option to act as fast as possible on threat containment. And that could be quarantining the endpoint or shutting down the switch port, etc., etc. So this is the content of this session today. We will look at network security, zero trust journey map for Catalyst Center to help you start utilizing this part of your zero trust workflow. Other aspects of zero trust in the workplace and other Catalyst Center use cases aren't going to be covered in today's session, but there is a ton of information available from Cisco, both online, from your account team, from your CX team, should you want to brush up in those areas as well. So before we actually start properly, just want to point out, just make sure you're aware, if you've got questions, definitely want your questions. The best way to do this is to, in your WebEx panel at the moment on the right hand side, should be on the right, you'll see Q&A, and if you don't see Q&A, you'll see this little Ipsilis button at the bottom right. Click on that, click Q&A, type your question in. Make sure that it says all panelists, because we are joined, as well as Miguel and myself, we have a couple of panelists here as well. And so make sure you've got it set to all panelists and click send. If a question, so the topics today are all interrelated, and so the general plan was to save those questions for the end, because we may cover answers to the questions as we go through. And so, most, if not all questions, we're going to cover at the end. But if one does come up that we need to chuck in, then either myself or Miguel or one of the panelists will just interrupt and message to the panelists. I'm happy to be interrupted, and if we need to. Okay, so let's get our bags packed for today for the Zero Trust journey. Miguel and I are going to have a lot of fun with this topic, including demos, give you information you need to explore the Zero Trust capabilities of Catalyst Center. So let's have a look at what we need to pack to start on this journey. We're going to need Catalyst Center, obviously, with the current recommended release, which is 2.3.7.7, and switches in the inventory in a managed state. You need your Cat9K switches, and the current release there is 17.12.4, and you'll need Advantage licenses to take advantage of the features that we're highlighting today. And as we're talking about our best bud ICE, the Identity Services Engine, you'll need that, and the current recommended release is 3.3 patch 4. Okay, so now we're all ready. We can start our journey. There are a lot of things to think about on the journey, but the main philosophy is the same as how you'd eat a whole elephant, just one bite at a time. So Miguel's going to go over our first topic of integrating ICE with Catalyst Center in order to achieve intent-based networking.
Good.
To you, Miguel.
Good. Thank you, John. So yeah, as you just mentioned, like the journey to Zero Trust can be full of distractions, and because of that, we need to have a clear path of where we need to go, or where we need to go through when we are, traveling to our final destination. So before we go into the journey, we need to have a good navigation system that we can plan our path, as you will do if you are going to a new territory, for example. So that's why we will need our navigation system. So Catalyst Center provides like full guidance to reach that destination. And that guidance is a Zero Trust journey map. So you can see that on the product, on Catalyst Center itself, and you will be able to see what are the tasks that you need to complete in order to achieve Zero Trust in your network, which is really good because you will be able to see the 3 aspects of Zero Trust and how you can configure that. What are the tasks that you need to complete to do that? And you can see also the percentage of tasks that you have already completed. So you can see what you have done and what you need to complete before you can achieve Zero Trust. So the 3 elements of this is endpoint visibility, network segmentation, and trust monitoring, and we will be talking about those aspects today. So here you can just select the components of your journey, and you can define if you want to enable CBAR or with Talos, and then you can see all the aspects or all the elements of achieving Zero Trust in your network on the Catalyst Center Zero Trust map. So as I mentioned, these provide full guidance to achieve your destination and to get Zero Trust, which is really good because, as we mentioned before, achieving Zero Trust has like a lot of moving parts that we need to have into consideration, and we will need to configure and manage. And with Catalyst Center, we have a clear view of the things that we need to do in order to achieve this. As you can see, you can explore the status of your journey. You can see the percentage of your journey so far, and you can see the recommended steps, the current steps, and then you can select the task that you need to configure. And here you can activate the suggested steps, and you can see a brief explanation of the task that you need to complete. So, and as long as you are completing them, you will be seeing the progress here. So you will be able to monitor and track your progress into your Zero Trust journey. So it is very, very useful and very complete map of the tasks that we need to complete for Zero Trust. So that is available on Catalyst Center itself. It's not like a new feature. It's been there for some time now. But yeah, really highly recommended to review this to get into your final destination, which is Zero Trust. So to start our journey with Zero Trust, we should have, of course, our Catalyst Center onboarded, our site hierarchy. We're going to talk a little bit on that. But there is one aspect that we really need, and which is integrating Cisco ISE, and that's what we're going to talk now. So as you can see here, we already have our Cat9K. Those devices need to be managed and inventory and reachable. But in order to have the visibility and the correct enforcement, we need to have ISE integrated with Catalyst Center. So everyone, for example, needs a friend to share interests, information, insights. For example, with John, since we are in the same team, if I go on PTO and when I come back, he just updates me on everything that is happening on the work. Or also if I am traveling anywhere, John will tell me, hey Miguel, do you know that you have this offer with this provider where you can get the tickets like way cheaper? So all that insights that is coming from John is really useful to me. So when we have friends with similar interests, we can have and share that information, and it's really useful. So, of course, this is not about John and I. This is about Catalyst Center and ICE, and it is basically the same. Catalyst Center, when integrated with ICE, will be receiving a lot of insights about context, trust, network devices, endpoint visibility, policies, and all of that. That is really necessary for us to have zero trust and identify the devices, that the devices are behaving as they should behave, as the device type that they are claiming to be. And all that insight is coming from ICE. And also, you will see that when we are creating our access policies, we are creating it in Catalyst Center, but it is ICE who is enforcing them. So this is a very productive and powerful relationship between Catalyst Center and Cisco ICE. And this is why we need to, as a first step, integrate Catalyst Center with Cisco ICE to achieve this zero trust environment that we want to achieve. So Cisco ICE has three main use cases with Catalyst Center. You have the network access devices. So for example, any devices that are onboarded into Catalyst Center are also registered with ICE. And also you have access control policies that you will be configuring those access control policies on Catalyst Center once you have the integration. But those policies are enforced, as I mentioned before, by Cisco ICE. So, and also when you are like authenticating your devices, so when you create authentication policies, when those devices are authenticated, that information, that insight is shared from ICE into Catalyst Center. So you can see if the devices has being authenticated, where they have been mapped, and the type of device so that they are. So you can see the endpoint authentication and poster status, and that is shared to Catalyst Center, and you can see that on the assurance page on Catalyst Center. So when you go to your Client 360 view, for example, you will be able to see the onboarding time and the authentication status of that device, thanks to the insights that Cisco ICE shares to Catalyst Center. So as a prerequisite, of course, to start working with this integration and to start enforcing our policies and achieving zero trust, we need to make sure that we have our site hierarchy in place, because Catalyst Center uses an intent-based deployment model, and that intent is defined with the site hierarchy. And you will see that the network settings, when you are configuring network profiles, applying configuration via CLI, for example, via CLI template, or managing software image upgrade. All of that is tied to the site hierarchy. So when you are defining a golden image, you are defining it on a site or an area. So that's why you need to have the site hierarchy in place before we start that. So the day zero and day end configurations are tied to this site hierarchy model. So for anyone who doesn't know what the site hierarchy in Catalyst Center is just a way to represent your organization in terms of areas, buildings, and floors. So you can have a country, and inside that country you can have an area. Inside that area you can have multiple buildings, and inside each building have a floor. And then based on that, you will be assigning your devices on those buildings. And then you will be able to manage your settings based on those site hierarchies. So we're going to see a little bit on that a little bit later. So, and also the telemetry also are coming on that, are tied to that model, to that site hierarchy model. So we're going to see that. So for example, when you are configuring your servers, which we will need to do, for example, after we integrate ICE with Catalyst Center, we will need to configure our authentication servers or AAA server. And in this case, we are configuring, as you can see, applying this setting in a global area, which is a default area under which all the areas that we create will fall. And you can create these globally. For example, as you will see, I'm going to select my client endpoint for network access control. I'm going to define this as add AAA server, and I'm going to define it as an ICE server. Define the protocol to be radius, and then we're going to define the IP address of our policy administration node of ICE. We can define multiple IP address on our ICE deployment. So we can define our primary and secondary servers. And I can define this globally, and then these settings will be applied to all the sites that are under the global organization. But if you want to go to a specific site or building and override the ICE server that you will be using, the IP address that you will be using, you can do that. But by default, this configuration will be inherited by the other site. And this is one of the things why creating our site hierarchy as a first step is really important, because then we will be able to manage those settings on our site hierarchy. So this is the ICE policy administration node, as I mentioned, and then you can have the primary and secondary servers defined. Then when you are ready to provision your devices, you will be able to see what are the changes that will be pushed to your devices. And this is a relatively new feature also in Catalyst Center, that you now have more visibility on what are the commands that will be pushed to your devices based on the intent that you have expressed on the Catalyst Center GUI. So you can see the provision, when you're provisioning the device, you can see the progress and the status of your provisioning. And again, how you can do that. So this is also a relatively new feature. You can see that before, if you have been working with previous Catalyst Center versions, for these type of configurations like applying VLAN, modifying ports, spanning tree parameters, BTP, all of these, you will have to go and create a configuration template to push these type of changes. But now you can automate these type of settings from Catalyst Center itself. So you now can go to your inventory, select the device that you want to configure, go to the device detail page, which is this one, and then you can go and apply these changes without having to deploy a CLI template. So after we have integrated with our ICE server and we have configured our AAA servers, the next step will be to configure the authentication and port configuration on our switches. So if we don't have SD access for a non-SD access deployment, we can go and automate these on the devices directly, as I mentioned before, just by going to your inventory, selecting the device, and then applying the configurations here. So for example, if I go to port configuration, I can select the interfaces that I want to configure, and then edit the global authentication settings. And then you can go to the interface level to edit any interface specific configuration. And then you also have the ability to select multiple interfaces and make changes at device level. And then when you click next, you will be able to deploy all these layer 2 configurations together. This is a major effort to bring like better automation from Catalyst Center. You can still, of course, if you want to apply any of this configuration using a CLI, you can still do it, but now you can do it on the GUI with Catalyst Center. So here we can activate our control policies for our network devices. This is something that we need to do. So we can, when we are editing these ports, we can go into the .1x configuration. And then if we need to add, show additional .1x configuration parameters, we can just click Add Configurations. And the default existing configuration can also be viewed. And you can see that the change. So just to demonstrate this, we're going over to John for the demo part. Oh, John.
Perfect. Right, bring up the dashboard.
Yep.
So let's look at the switches. So reachable and managed, as Miguel said. So let's check the layer 2 config. And the authentication mode is disabled. We want to enable it to use auth on our switch. So, and also see TrustSec is not fully configured. So we assign a group tag of 2 to the network device, enable the enforcement for a certain range of VLANs, which should be the client VLANs. What's going on, Miguel? Show dashboard.
Oh, see what happened. Yep.
Okay, so we're going to choose interface, where we want to look at the .1x settings. So let's jump in here. I can see it's in open mode. So let's set that to closed. And here is a list of attributes that we can use. So we'll choose host mode, re-auth timer, multi-auth is okay. And we'll change the timer for demo purposes as well. And let's go down and have a look at Cisco TrustSec, so CTS, and nothing is displayed. So check the role-based enforcement is set, it's already enabled. And we'll go next. And we'll choose when. And we'll look at the config preview when it comes up. So this is a really great feature. It shows you what config is going to be pushed. So it will show you the running config. You'll see that on the right-hand side. And then on the left-hand side, it shows you what's going to be pushed. So you can see a couple of CTS commands enabling TrustSec and some commands on the 02 interface. If we hit deploy, next, wait a few seconds. And then we go back to the inventory of the device. Let's have a look at that layer 2 config now. Auth should now be enabled. Let's have a look. Yep, auth's now enabled. TrustSec enforcement should now be enabled as well. And the port config, now let's have a look, shows the non-default configuration we have pushed. There we go. So the TrustSec settings are the same as before, as we didn't change the default. Let me go back to you, Miguel.
Good. Thank you, John. Excellent. So this part was for non-SD access deployment, for example, when you need to enable authentication for those devices. But with SD access, you can just select the authentication templates that you want to use. And you have these open authentication templates, which just will allow communication to the device without authentication. You can receive all the services, DHCP, TFTP, and other services. You also have low impact, which is limited access before authentication. For example, you can allow the device connecting to the switch port to receive an IP address before authenticating and then authenticating into the network. Or you can have the close template, which will not allow any configuration or any services through that switchboard. Only the authentication protocol or the authentication traffic that needs for the device to be authenticated on the network. So, but the good thing about this is like you can select the template, express your intent on Catalyst Center, and then Catalyst Center will be applying the configurations that you need to apply on your network devices to get these results. So as you can see, for example, here we selected the close authentication template, and we are defining these different parameters like the deployment mode, the authentication order, the fallback timer, and these parameters. And you can see then the equivalent of the configuration that Catalyst Center will be pushing to your switches. So for example, in the case of the deployment mode, you can see the commands being generated, the access session closed. Then you can see the first authentication order. You can see the commands being generated here. And the fallback timer, you can see it on this part, the blue time, the .1x timeout. And the number of hosts, you can also see it here on the access session host mode multi-authentication. So this is really good because on this case, you don't need to worry about the syntax. If, for example, you're managing multiple set of devices, you don't need to worry about the command syntax or the commands that you will need to push to your network devices. You just need to express your intent into Catalyst Center, and then Catalyst Center will be taking care of those configurations. So when we are defining our access policies and we are defining our segmentation and our authorization policies, what are our authorization enforcement options? So traditionally, we have been using VLANs to segment our users, and we can also have a dynamic VLAN assignment, like when the user authenticates, then the radio server will be assigning the VLAN. But normally, we will be also tying VLANs to subnets. This is the traditional way of doing it. So for example, you can assign a subnet per VLAN and then using access list to filter or to manage the traffic or to define the authorization between those different VLANs, which will be created based on different groups, for example. But the downside with this is these policies will be tied to a subnet, and normally those subnets are tied to a specific location. So for example, you may be having a VLAN managed on a different set of switches, and those users will be affected by the policy that you define on the VLAN as long as they are on that VLAN. As soon as they move into another type to another area of the network, receive a different IP address, that policy won't be the same. So that poses a challenge. And also when you are using an access list or the downloadable access list, for example, that you can assign dynamically, but it is still a challenge and a lot of overhead, and it can come with a lot of inaccuracies as well. So the recommended mode or the recommended option is security group tags. So using like group-based policy, the SGTs are a 16-bit field that it is carried on the VXLAN package, and we're going to be talking a little bit that later. But the main idea here is that when you are using SGTs instead of VLAN and access list, you will have a lot of more flexibility grouping your users and then defining the access types or the type of traffic that can flow between those user groups. And something that is really important here is that these groups are topology independent, and they will be traveling with the user. It doesn't matter where the user connects in your network, that policy will be going with them anywhere in the network. So you can have also uniformity on your policy between your, for example, your wireless network and your wired network, which give you a lot of powerful when you are trying to manage the type of communication that you want to have between the different groups. So as I was mentioning, the big value of these SGTs or group-based policies is the enhanced simplicity for better enforcement and management. So for example, here you have your individual users in the workplace. And then you, based on this, on the things that those users have in common, or the type of requirements that they have, the type of access that they need, you can group those users. And here you have a sample of user groups. For example, you can have your employee, partners, contractor, guests, visitors, or any type of group that you need from your user's perspective. And then you can go into the resources, servers, or services that you have in your network, and also create your individual groups. So for example, here I have a sample server groups, which will be like the destination. And then once I have my grouping here, then I can define the type of traffic that can flow between those groups. So I can define what type of traffic can flow between employees and the sensitive servers, or the contractors and company confidential servers. And once that type of policy, we call access contracts. And that gives us a lot of flexibility in terms of what I want to allow or block between my groups. And it gives a lot of flexibility because, as I mentioned before, this is topology independent, and it will be traveling with the different users. So if I have a user on the employee group, it doesn't matter where the user is in the network, it will be affected by the policies that I have defined with my access contracts. So ICE will be also sharing a security information in terms of when our user is authenticated in the network. ICE will be automatically assigning that user to the group, and then that IP to group mapping will be shared to Catalyst Center, and also to other Cisco appliances like Security Firewall, Cisco Secure Web Appliance, or any device that supports PXGrid or can be a PXGrid subscriber. So ICE, when the device authenticates, it will receive an IP address. It will be assigned to a group, and all these insights will be shared by ICE to other platforms, not only Catalyst Center. So this is where you can see the insights that Catalyst Center, that ICE is sharing to Catalyst Center. So once a device is, a user is authenticated, you can go to the client 360 view, for example. You go to assurance, health page, client section, find your client, and then there you will be finding your client information. So this assurance information, like authentication, association time, the onboarding events, all this information is coming from ICE. So this is also this is one of the things why it's important to have ICE integrated with Catalyst Center, so we can have more visibility of what's happening with our devices. So of course, we won't be covering how to integrate Catalyst Center with ICE, although this is like a fairly simple process, and there's a lot of information that you can find on how to do that. But we just wanted to point why it is necessary to integrate ICE with Catalyst Center for Zero Trust Network, and what are the benefits that you can have once that server is integrated with Catalyst Center. So we have also covered. We have connected ICE in our journey. We have pushed the AAA configuration to our devices, control access, grouped endpoints, and we share context thanks to ICE. So now the next steps will be to have better visibility. So as you can see, all this that we have done now is just to complete the ICE integration. So now we need to go and work on having better visibility on our network, or better endpoint visibility. So as a next step, yeah, I'm going to you, John.
Awesome stuff. Let's jump straight in. Okay, so I'm not going to ask you to, let's move our Webex off that screen. I'm not going to ask you to do any slide or anything like that, but just mentally, because I'm going to use my telepathic powers here, mentally hold your hand up if you think your network looks like this picture on the left. So it's perfectly segmented, All devices are known, all contracts are well defined. Everything is pretty neat like this. Now, I can't see any hands up. Or does your network look more like this picture on the right, where you know some endpoints, probably the managed endpoints. You have some segments, but not a lot. And you have a lot of unknown devices that put in one or a few default segments. Yeah, I can see a lot more hands going up. This is what we kind of normally see. But obviously, the dream, the goal, is that picture on the left-hand side. So what's the reason behind this? There is a huge increase in the number of unmanaged devices like IoT and OT devices. Most of these unmanaged devices don't support proper authentication mechanisms like .1x or certificates, and they're mainly found in open, unsegmented networks, which obviously, as we saw with the smart thermostat, can be a risk. So what can we do? Let's have a look at these two people here. These two are fine. They're using .1x. They've got managed devices. But these two devices, they can only be identified by MAC address. And this isn't proper authentication. As the name suggests, MAC authentication bypass, it's a bypass of the authentication. So you require a database, which you probably have in ICE. But if the MAC address is not in there and you have an OT device, then there is probably a catch-all policy anyway. So MAC authentication bypass is a necessary evil. It has to remain, but we need to make it more secure. MAC addresses can be easily spoofed. So anyone could join a network, say their MAC address is the same as the fish tank thermostat, and gain access to everything the thermostat has access to. An attacker could also spoof attributes as well. And these could include attributes like things in the DHCP header, like the vendor of the thermostat, etc. Our solution is to use Catalyst Center AI Endpoint Analytics. Try saying that a few times fast. We want to go from unknown devices to only known devices. That's the ultimate goal. We use multiple sources for this, not just ICE with ICE profiling, but also sources like DPI, Deep Packet Inspection, onboarding tools where you can import the MAC address, and attributes including device type, software version, so on and so on. Catalyst Center aggregates all of this data, plus gains insights from a cloud-connected part. You can see cloud-connected part of the solution up here. That isn't strictly necessary, and we do see some organizations that are maybe air-gapped and can't have internet access, and that's fine. But it is recommended, though, that if you can, do connect to the cloud, for you get full functionality and usability of the AI endpoint analytics. So what's needed then is to learn 4 factors for each and every endpoint. Profiles for each device are now made up of 4 factors. So you have manufacturer, model, the OS, and the endpoint type. ICE and Catalyst Center share this information. So ICE shares what it learns with Catalyst Center, and Catalyst Center shares the details from the DPI, the Deep Packet Inspection. If you have CyberVision, which is another product from Cisco, which isn't in focus today, this is a fingerprinting engine specializing in OT devices. This also integrates a ICE as well, and obviously that data feeds back into Catalyst Center. So the benefits here include easily setting a policy based on these 4 MFC attributes, the multi-factor classification attributes, as well as compatibility with Cisco's AI and machine learning profiling engine. So let's have a look at the DPI piece then. The orange line here is what you might already know. This is simple profiling already done by ICE, and information is shared between Catalyst Center and ICE, as I said. So if you have a shared database, and the management is done on the Catalyst Center side. Then we do a first packet classification. So we look at the first packet of a flow, and based on the destination port, protocol, IP information, we gain a lot of details straight off the bat. And then secondly, we also use the SD-AVC engine, which is a lot of acronyms. And as you know, we do love our acronyms here at Cisco. The SD-AVC engine, also known as NBAR, another acronym. This is the network-based application recognition feature. So Catalyst Center will use this NBAR engine. It's the engine that looks at the data plane packets on the switch. Usually NBAR is used to specify and recognize applications, but here we're also using it to derive the endpoint type. So it's a feature that already existed in Catalyst Center, but we've kind of switched it around. So we're not as interested in the application, but more interested in the other aspects of that packet, namely what device is sending it, where it's going, what the protocol is, etc., etc. So we've added more functionality to the NBAR, which altogether gives us more of a complex classification. So what about machine learning then? So we know about some devices. So you can see here, iPhones might already be known, but there are some unknown devices. Catalyst Center finds out that there are similarities to these unknown devices. So there are clusters of devices shown here in orange and green. We don't know what the devices are yet, but we have found out they have similar traffic patterns, traffic pattern attributes between them. So we've kind of kept them as orange and green. Then we create rules out of this learned behavior, and we label those devices. So here we're looking at the lights and the thermostats, and we've labeled them lights and thermostats. So these rules are then shared with the machine learning cloud. So this is where this AI and machine learning cloud comes in. And so if any similar device types are seen elsewhere, and this could be anywhere in your network or any network around the world, then the traffic patterns and traffic attributes are seen, and the AI cloud will automatically suggest labels. And then the Catalyst Center admin can decide if they want to accept or reject the suggestion. So some of these features are based on the Cisco cloud. We do have different zones around the world. So you could choose your local zone. I know nearly everyone that I work with, all of my customers choose EU because nearly all of them are in the EU, and we have different laws around EU than anywhere else. Every region has data privacy sheets outlining what data is sent, and ultimately there's no personal information, no corporate information. It's all patterns of the traffic analytics and stuff like that. But ultimately, you can see here the features that are gained from each different region. So let's have a look at the user interface then. What do I need to enable it? The landing page is a setup button, and it takes you to the day zero setup wizard. In this wizard, you need to enable three things. As mentioned, the cloud piece is not mandatory, but recommended, as you have more granularity in identifying the endpoints. So the first step is activating the deep packet inspection. CBAR is similar to NBAR. The C stands for controller. So Catalyst Center is managing the function on all the switches. And from version 2.3.7, this feature is enabled by default on devices when they're added to a site. So that's good to know. The second step is to enable ICE integration. We've already integrated ICE, but we need to enable an enhanced integration. This means we need to share the profiling information between the two. So just turning on these two options here will do this. And one is for the ability to send information to ICE, and the other is the ability to receive ICE from ICE to Catalyst Center. And the third step is to enable the cloud integration. So there's a global switch called AI Network Analytics. This is like a transport pipe between Catalyst Center and the AI cloud. Once you've enabled this, you can choose which additional functions you want to enable. So this would be the endpoint smart group and the AI spoofing detection. Sorry, can't speak now. And you can see at the bottom, you can choose which DC you want to use as well. So we've enabled the three settings, and you can come back here and check this at any time. So then we go and look at the results from the endpoint analytics. So we have a number of endpoints and the status. We have a few we have how many are unknown. So in this case, there are 0 unknown endpoints, but it will show you how many are unknown, how many of those endpoints are fully profiled, and how many are partially profiled. And partially profiled means that out of the 4 factors that we mentioned earlier, maybe we know 2 or 3 of them. We can see a trust score in the middle, and we're going to talk more about trust scores later. And we can see the AI proposals on the right-hand side. And these are the suggestions for the administrators, like, we think these are light bulbs, which the admin can accept or reject. When we go to the next tab, we see the endpoint inventory of current or formerly connected devices. And we also see the attributes, the endpoint type, the OS, all the 4 factors. Based on the authentication from ICE, we see the username, auth status, and the auth profile as well. Also from 2.3.7, all the attributes are shared into assurance. And so, so while this isn't anything to do with security, when you're working in the assurance areas, for example, here you're on the client health dashboard, you will see all the 4 factors or the profiled factors from the security side, the AI endpoint analytics. So added bonus when you're working with assurance. APIs are also available, so you can activate, configure, and use endpoint analytics from the API. Recently, we've added the try button. This is in the last couple of versions. So now this try button actually makes a call to your Catalyst Center, so you can see the actual data that you would get back from the API endpoint. Once you've enabled endpoint analytics, you unlock an additional dictionary within ICE. It's called the Endpoint Analytics Dictionary. And it includes the device info, as well as the 4 main factors that we talked about. Those attributes can also be used in the authorization policies. So there's a direct correlation here between the MFC types, the attribute types, and then creating the policies in ICE. So let's create a policy then. I want to look for thermostats and see if I know the MAC address. And this is exactly how we would have done it with MAC authentication bypass. And as we've spoken about, this is insecure by itself due to spoofing. Anyone can say, I'm a smart thermostat, and straight away they get access to everything that's got the smart thermostat has access to. So let's add some more attributes. Now I can add attributes like type equals thermostat and manufacturer equals Sharky. And this isn't as secure as .1x with certificates, but it's more secure with multiple attributes over just MAC authentication bypass alone. So if I know the device, I allow access to the network, I assign it to my IoT segment and give it a group tag. Okay, second example then. I know it's a thermostat, I know the MAC address, but not the vendor, as I might have started using a new vendor. So we've set here hardware manufacturer is not Sharky. So I assign a different SGT, or I could automatically just deny access. So we finished our first segment on our journey map and gained a better endpoint visibility. We've enabled CBAR and profiled and grouped our devices. I think it's time to move to our next section, network segmentation. So Miguel's going to take us through this section, starting with the network fabric.
Excellent. So now we are on the network segmentation part of the journey. And of course, in order to apply policy, network segmentation is a very foundational part of the process. So we do, to do like a proper network segmentation, we'll be using SD access. So for zero trust segmentation, we need to have SD access. So that is why we are describing in a foundational or introductory level, what is SD access or what are the different components of it. So SD access, okay, SD access is like a software application that is used to automate wired and wireless campus network, and also allows us to automate user device policies for any devices or user in the wireless or wired network. The different components of the SD access solution are the overlay and underlay. Because basically you will be defining a virtual network um, that will be independent of any topology, and on which you will be able to apply the policies that you want to apply, restricting or allowing the traffic between your different groups. But yeah, to understand what is SD access and the components, we first have the underlay, which is your network, your traditional network on which your virtual network will be running. So the overlay network is composed of the control plane, data plane, and policy plane. And the underlay is also based on ISIS. You can also use OSPF or BGP EVPN is planned also as a second option. But by default, when you use LAN automation, as we will be discussing in a few minutes, ISIS is a protocol that is configured on the switches or your network devices. So on the overlay, the control plane is based on the LISP protocol, and that is what allows us to decouple the identity of a device versus its location. And that is one of the things that provides us the flexibility and mobility that we have on SD access. We have the data plane, which is based on VXLAN, and this is the protocol that is used to create the tunnels between the different devices that on which the endpoints are located. And we have the policy plane based on trust sec, and this is where we define our policies, our access contracts that we define, and the SGT taggings that we mentioned before. This is basically where we define our policies between to establish a communication between the different groups that we have created. So when we start the deployment of SD access, we can do that specifically on the greenfield deployment, new deployment. We can use LAN automation. And why should we use it? So LAN automation allows us to first discover one or two core devices, and then discover the rest of the devices in the network, and then configuring all the necessary settings on those devices. So for example, for a good underlay, it is recommended to have ISIS configured, to have layer 3 point-to-point links between the distribution, for example, and access switches. And we need to have also our Anycast interfaces. All that configuration is just abstracted, so you don't need to worry about that, and Catalyst Center will be configuring it for you. So that's one of the main benefits of LAN automation, although it is very prescriptive for new deployments or brownfield deployments, but that is the big benefit. So everything is automated for you, and then you will be basically discovering your network, your new devices, and configuring them, having them ready to configure the fabric on top of it. So once you are ready with your underlay, you have used LAN automation to onboard and configure your underlay network. Then you need to configure your fabric. But before you can configure the fabric or the SD access fabric, you need to understand the roles on the devices on that fabric. And the first role is the edge node. And this is where all the endpoint or client devices will be connecting to the network. You can have your access points there connected, your laptops, computers. So this is where your endpoints will be connecting to the SDA fabric. Then you have the border node, which will be connecting us to any external layer 3 and layer 2 network outside of the fabric. So any communication to external services, the internet or external route or anything outside the fabric will need to go through the border network or the border node. And then we have the control plane node, which is like the map system or that allows us the tracking of the endpoints. And this is where we see the magic of Lisp taking place. So for example, when we have a device on one switch and that device needs to connect with another device to another switch, in order to create the tunnels that we mentioned with VXLAN, those switches need to know where that endpoint is connected in order to establish the tunnel between the different edge nodes. So that tracking of endpoints and the endpoint ID and location is done in the control plane. So, and this is done with Lisp. And we're going to see a little example later on how this come into place to protect our network and how that works, so we can understand how, for example, in the case of the thermostat that we had in our tank, could have been blocked and avoided the attack that we mentioned before. So any network that is part of your underlay network, any network device that is part of your underlay network, and that is not participating in a fabric role, is referred to as an intermediary node. It's just a network device that is not participating on the fabric, but it's just sending traffic. So as we are talking about segmentation, and after we know the different roles on the SD access fabric, how segmentation works in SD access fabric. Segmentation works in let's call it in two layers or two levels. We first have macro segmentation, which work with what we call virtual network, which is effectively VRF in the underlay network. And then we have micro segmentation, which is where we apply the SGTs that we mentioned before. So, for example, this is the first level of segmentation, and it ensures zero communication between forwarding domains. So you can specify for your campus network, you can specify a major virtual network, which we'll call it, let's call it campus VN. So, and then for our IoT devices, we can specify then another virtual network, which we will call IoT VN. And by default, communication between virtual network is restricted. So you cannot communicate between those two virtual network without having to go outside the fabric and then configuring what we call VRF leaking between those virtual networks. So by default, you won't be able to communicate between devices on different virtual networks unless you do some sort of VRF leaking. And of course, redirect the traffic outside the fabric. So the next level of segmentation will be the SGTs, or micro segmentation. And this second level segmentation ensures role-based access control between the groups in a virtual network. So for example, we define our campus VN virtual network, and then in the campus we can have the groups, as we mentioned before. We can have let's say, accountability, contractors, and any other type of groups that we may create in our campus network. Then we can specify the type of communication that will be allowed or restricted between those groups within that virtual network. And that's give us like a more granularity and flexibility in terms of how we want to declare our policies or access policies. So here, for example, you can see we don't have communication between campus VN and IoT, because by default, you don't have communication between different virtual networks. And then within those virtual networks, you have your different groups. And there you can restrict or allow the communication as you need within those virtual networks. So here we have these devices, like the lighting devices and the thermostat, and we are restricting communication within that IoT virtual network. And this is what we call an access contract. So when you define the policy, like allow traffic for this specific protocol between this group and this other group, or restrict traffic from this specific port or protocol from these different groups, this is what we call access contracts on Catalyst Center. So for the demonstration on segmentation, so we're going to go to John.
Awesome stuff. Okay, so to set up the first step then, so from the home page, set up macro segmentation, which is our VN networks. You need to go to provisioning virtual networks. As you can see here, there are 22 layer 3 VNs in this Catalyst Center dashboard. And when you click on them, you get taken to the layer 3 VN table. And this is at the global level. It shows you the VN name, the VN ID, the stats on the number of fabric sites, gateways, etc., etc. So let's go and create a new layer 3 VN. So click on here, you can follow the wizard. First step is to give it a name. So we'll name it campus. We can add another one, we'll call this IoT, and we can add as many as we want. Okay, next we need to assign the SDA fabric sites to the VN. This is why the first step is to create the fabric sites, as you need to assign to the VNs afterwards. Assign these. Next. So you choose when you want to deploy. So we'll just deploy now. And then Catalyst Center runs some checks to see if there is anything that may cause an issue, like compliance checks, etc. And we do actually have issues here. I'm guessing that the switches are not running the golden image software version, but we can ignore this and deploy. We'll submit and deploy the task. Yep, so all good. Submit. Okay, so back on the table, you can now see the new VNs which are set up. So we've got campus VN, and you can see it's now assigned to a fabric site. You should see our IoT VN, yep, assigned to a fabric site as well. And that's them done. So we need to set up micro segmentation now, also known as security groups. So you go to policy, group-based access control, and if you go to the security groups tab, this table shows you the SGTs, so the names, the description, the tag value. So the tag value is really handy if you're troubleshooting. You need to know that, and the number of policies that are using this SGT. So if we go and look at cameras, for example, you can see there are 4 policies using this SGT. If we look at them, you can see the contracts associated with them. So for example, traffic from the cameras to the developers has been denied. If we want to create an SGT for the thermostat in the fish tank, we just give it a name. Let's call it Aquatemp. And we assign it a value. And click Save. Once that's saved, we then deploy it. Great, deploy. Yep, once that's done, we go to the policy matrix. We should see it there. So go to policies. So we should see it in the policy matrix here. And you can see Aquatemp is there. You'll see sources. The source traffic is on the downward, the left-hand side, and destination on the right-hand side. So what you can do here is it's as simple as just picking a cell. So you choose your source and destination. And like Aquatemp servers, default policy is permit IP, and we can change this to deny IP if we want to. So we'd click it and we change the contract. And then there's some default ones to start with, or you can create your own. So we'll just go for the deny IP. We'll save that. And then after applying it, the color you see from the matrix, the color is now changed to red. So this is obviously now denying the IP. It gives an easy visual way of seeing the policies. This is only one way. So we've only gone from the Aquatemp SGT to this the servers SGT. So if you wanted the reverse, then you'd do the reverse box as well. And just so you're aware, the color key here, red is obviously deny IP because that's what we've just seen. Green is permit IP, as you probably guessed. Then you have gray, which is the default policy, and yellow is customized. So for example, you could deny web traffic with 2 actions, and those actions could be deny HTTPS and HTTP. Back to you, Miguel.
Good. Thank you. Good. So as you can see, the security group rollout as we saw, we're going to see a little example on how this policy works. So as we saw, we will be creating the policy on Catalyst Center. So and we can also create our groups and our access contracts and all of that. Then that policy will be sent from Catalyst Center to Cisco ICE, because Cisco ICE is the enforcer in the end. So Cisco ICE will be pushing the configuration to the switch, but not to all the switch, just the switches that need that configuration to be applied depending on the policies that you are configuring. So as we saw now, we just John just created a policy denying IP traffic between the thermostat in the fish tank and the server. So that configuration will be pushed on the devices, for example, that have the thermostats, the device that has the server connected, and or the devices that have the servers connected. So then this policy will be pushed from ICE to the network devices for enforcement. So as an example here, we have, let's say now after we have applied this policy that John just shown before, let's say that we have now the hacker trying to communicate with our servers using the thermostat. So you see that by default, you have these permit IP, but we also have defined this policy denying traffic between the thermostat and the server. So when that happens, when we have traffic coming from the thermostat to the server, the switch, when the thermostat sends traffic to the switch one will try to know where the server, the thermostat is trying to connect, is located. So this is where the control plane come into place. The switch will be asking the control plane node, hey, where is the switch to, or where is this, where is this server located? So the control plane will know where this server is located, and it will tell, hey, this is connected to switch 2. So this is the locator of this endpoint, which is switch 2. Then switch 1 will try to create a VXLAN tunnel directly to switch 2 to start sending the traffic. But on that VXLAN tunnel, you have these SGTs defined on the header, and the switch also have already received the policy from ICE indicating that IP traffic from the thermostats or this Aquatemp group to the server will be denied. So when the tunnel is sent and this switch receives the traffic, it will be seeing this policy and it will be automatically dropping that traffic and restricting the communication between the thermostat and the server as we just specified on Catalyst Center. And something that I really like about this is how intuitive it is, and we don't need to worry about pushing any commands or pushing those commands to specific devices, as we will do in a traditional way. In a traditional way, you will need to identify the traffic that you want to block, the commands that you want to push to block the traffic, the devices on which you need to apply that policy, and the interfaces on which you need to apply those policies. So all of that is removed from a management perspective, and you are just expressing your intent on Catalyst Center and specifying the policy in a very intuitive dashboard. And then this is enforced by ICE, so which is really, really easier than the traditional way. So here you can see the different groups and the policy, and in the end, you will be blocking that traffic as defined in the policy. And something that you can also do after you have defined your policy, you can use a group-based policy analytics on Catalyst Center. Will be showing you the real flow of traffic between the different groups that you have specified. And based on that, you can refine your policies as well. So here you can check if the policy that you have defined are being correctly enforced, and also you can check if there's something that you missed in the policy. So if, for example, in our little example of the Aquatemp group and the server, we can come here to the policy analytics, group-based policy analytics, and check the traffic between those two groups. And if we can see other type of traffic that we don't like, then we can go and create our access contract based on that. But this gives us real-time visibility on the type of communication that is happening between our different groups, and that will allow us to have the information that we need to refine or create our access contracts. As you can see, you can explore the traffic flows. You can just hover your mouse between the different groups, and that will be giving you like the unique traffic flows. And then you can drill down and see what is the type of traffic that is flowing between those two type of groups that you will be able to see. The protocols, ports, and type of traffic that is flowing between those two groups. As you can see here, for example, energy control and lightning, you can see the type of traffic that is going through and the flow counts. So let's say, for example, that you now see that you are having telnet traffic between those two groups. You don't want to use telnet because it's an unsecure protocol. Then you can go and define your access contract based on that. And you can even see, you can create reports, review contracts to then edit it, to refine it, or you can just go and create a new contract to specify the new policy that you want to specify. So here you can see the ports, and as I mentioned, view the contract. So at this point, we have segmented our network, and we have created our policy. We saw how that being worked between the different groups. So we have visibility, segmentation, and now we need to go into the next milestone. So yeah, go back to you, John.
Perfect. So, still the ball. Move WebEx off my screen. There we go. Okay, so we did see this. We saw this slide earlier. We're going to talk about trust monitoring. So the fish tank example came about because the attacker spoofed the MAC address of the thermostat. They had no clue that the endpoints were being spoofed at all. Before we look at anomaly detection in Catalyst Center, let's look at different ways spoofing can occur. So firstly, there's MAC spoofing, as we spoke about earlier. This is where somebody uses the MAC address of another client to access the network. And then we also have attribute spoofing to hide behind those spoofed attributes to gain access. And this could be something like an impersonation attack. So let's have a look at how we can solve the problem and give customers the warning of these anomalies. Catalyst Center is collecting a lot of telemetry data. There is a feature called Trust Analytics. Catalyst Center is calculating a trust score for each client. So this ranges from 1 to 10, and the higher the score, the higher the trust. So, and if the score is dropping, then it's because there's anomalies in the client or the traffic or something like that. So let's have a look at what it's used to calculate the score, because obviously that will give you a better understanding of what the score means. There are a number of KPIs which you can enable. There are positive influences which increase the score, like a secure authentication method, .1x, or the posture compliance, which is based on ICE. And there are negative influences. These drop the score, for example. So there's NAT mode detection. If you run VMs or containers that are NATed behind your host IP, or Talos IP reputation. If you Talos maintain a list of bad IPs, and if your client device is accessing these IPs or websites, then again, the score would drop. Catalyst Center can identify concurrent MAC addresses, maybe if the attribute labels change over time. So that you've got a client which is reporting it's a MacBook, and then suddenly it becomes a Windows device. Something's a bit suspicious there. Maybe there's weak credentials of clients, and these can be scanned and detected, and therefore you have a lower trust. If spoofing is detected, or if you have a client that is scanning open ports. So let's have a look at some examples then. Firstly, a positive example. We have a colleague here. His name is Miguel. Hi, Miguel. is using a secure authentication method with his devices, and his devices get a score of 8. Now his devices are also posture compliant, so the trust score would go up to 10. So it's the highest score possible. This means that Miguel's devices are trustworthy and no anomalies have been detected. So in Catalyst Center, this is where it will show you the endpoint table with the trust scores, and you can select the trust scores, and it gives you the factors that have gone into deciding on the score. Now, if you have a look at a negative example, so we're looking here at Bob. He's using a secure authentication method, so a score of 8, but he's accessing a bad website. Thanks to Talos, we know the website is bad, so the score drops down to a 3. Or similarly, concurrent MAC addresses. The attacker is spoofing the MAC address of an IP-based phone, and when looking in Catalyst Center, this is what we see. So you've clicked on concurrent MAC address, and it will show you both the devices and the details of both devices that are seen with that MAC address. Miguel's going to run us through a demo.
Yep.
Okay.
Good. So the first step, we need to go to the menu icon and go to policy, because this is part of the our policy. Go to AI Endpoint Analytics, and here we can see the trust score of our endpoints. So we are detecting here 27 endpoints. Out of those, we have 2 with a low score, 25 with a medium score, and no endpoint with a high score. So yeah, we have some work to do here in this network. So when we click on the trust score, we can see the devices being tagged with these scores. You can see if the MAC is randomized. We can see the trust score, and we can see the authentication method. In this case, wire MAC MAB, and we can see also the AI spoofing detection. So it is being marked as a low trust. So clicking on the device, we can see the details and what is happening here. If we click on trust score, we can see the endpoint context. We can see the authentication method, which is affecting the score. And in the AI spoofing detection, it looks like this device is posing to be an IP phone, but it is not behaving as one. And this is something that I really like. So based on that, we can then apply the adaptive network control policy. And here we can specify different policies that John will be describing later, but we can specify if we want to re-authenticate the device, put it on quarantine, or just shut down the port. And these policies, of course, are created on ICE, and then we will have them available here in Catalyst Center to specify what we want to do when we have a device with a low trust score. And this is really, really important. If we go back to the example of the thermostat, that thermostat shouldn't be sending or downloading information from any other part of the network. So with Catalyst Center, that will be detected, that it is evident that this device is not behaving as the type of device that is claiming to be. And based on that, you will be able to see that and take action as well. So yeah, this is just like a short demo. So yeah, back to you, John.
Perfect. So what kind of options can ICE offer them? So firstly, quarantine. You can give it a different SGT and quarantine that endpoint. You can shut down the port. This is a blunt tool, but sometimes effective in the right scenario. You can restart the authentication process, or you can cycle the port where the endpoint is connected. ICE needs to be set up for ANC policy for you able to do this in Catalyst Center, but thanks to the integration, you get full visibility within Catalyst Center while ICE is doing the threat containment. Now, I've heard some people say that, yeah, this is great and all, but I need to go into dashboard to monitor, then manage these devices. Well, this is only partially true if you go down the manual intervention route, which you don't have to do. This is just temporary. You can start to automate the process, and there are some different options available. So firstly, you could use APIs. So you can use the full API suite to do this process for you, or you can do it within ICE. So earlier we spoke about authorization policies in ICE, but now we're also including the trust score. So here's our one from earlier, but now we're also saying greater than 6 on a trust score gives you a good SGT. But if it's untrustworthy, so exact same as earlier, so we know the MAC address, device type is thermostat, manufacturer Sharky, but it's a poor trust score, then give it a SGT of bad fish, which you can apply different policies to. So Catalyst Center is continuously managing the trust score based on the client behavior. It's not a one and done. If that client initially gets a trust score of 8 or 10, later on that can automatically be changed while the flows are, while that client is actually connected. So if for example, a client starts accessing bad IPs, then the trust score would decrease. And ICE would then do a COA, a change of authorization. And as part of this process, it would possibly apply a different SGT based on the rule sets, which would give the access policies applicable to this new SGT. Okay, so that is the last section with trust monitoring. We've now completed all of the segments on our journey to build a zero trust network. And you have seen that some have been completed with SDA and some without. At the beginning of our session, we didn't know where to start, or we didn't know the items we needed, and we didn't know which route to take. But integrating the best buddies of ICE and Catalyst Center, we've showed you our recommended path. And using the zero trust journey map, you've seen lots of advantages while doing this. So we started with endpoint visibility, and then we continued through and spoke about network segmentation, and then we finished with trust monitoring. Now it's time for you to continue the journey. So the first steps I recommend is to upgrade to the recommended versions of Catalyst Center and ICE. Then continue your journey step by step. So you'll see the journey map within Catalyst Center. Just go step by step through that. Also, get support from your local Cisco partner, from your customer experience team to finish your journey. Okay, thanks for staying with us till the end. Now we're going to have a look at questions. When you do leave, there is going to be a survey which pops up. Your feedback is really invaluable to us, so do spend the 20 seconds it takes to just go through that survey, and just give us your feedback. Rate Miguel and I on how awesome we've been, or not, if that's how you feel. And let's have a look at the questions. We've got some, actually, before we look at the questions, you've got a couple of links here as well, cs.co/catc. This will give you events, recordings, and additional resources. And then there's also an email address you can email if you want to get in contact with the customer service team.
I must say I'm amazed. Thank you, John. Thank you, Miguel. You are on time. I just sent 5 minutes ago, sent a message for an extension, but we didn't need it. Great presentation, great demos. One note for the link you just mentioned, it's in the chat, the correct one. Regarding the questions, we had quite a few, but they are all answered. So we have responded to all questions. If you have any more questions, you have a couple of minutes to post them, and we will respond. Or you can contact us in the email John published.